Let's have a look at question 7. Let's read the question first. So, a wooden crate of mass 20 kg. So, if the mass is 20 kg, that means the weight should be 20 g. And then that would be a normal reaction R. We can label here. And it's pulled in a straight line along a rough horizontal floor. So, if it's a rough horizontal ground, so that means there has to be a friction using a handle attached to the crate. The handle is inclined at an angle alpha to the floor as shown in figure 1, where tan alpha is 3/4. So normally I don't use the tan inverse, we will call the angle. So if they give us tan alpha equal to 3/4, those nice number, I just draw a little triangle. So this is alpha, so tan is opposite over adjacent. So that means opposite has to be 3, adjacent has to be 4. And then by Pythagoras theorem, so 3, 4, this has to be 5. Yeah. Or we can just put in the calculator, square root of 3 square plus 4 square. That should give us 5. So that means sine alpha is equal to 3/5, and then cos alpha is equal to 4/5. You can work out angle using tan inverse and substitute. Both works. This will give us exact value. Sometimes when you work out the angle, you won't get exact value. That's why I always do this. Okay. And then the tension in the handle is 40 Newton. It's already labeled in here. And the coefficient of friction between the crate and the floor is 0.14. So we know there's a friction because it's a rough horizontal ground. So that means friction is always opposite to the moving direction. And then we know it's equal to mu r. So mu, they already gave us 0.14, and r, we just put it r. Okay, and then the crate is modeled as a particle, and the handle is modeled as a light rod. Using the model, find the acceleration of the crate. So because the particle is moving in the horizontal direction, like moving in this direction. So that means it's better to resolve all the force either in the horizontal direction or is in the vertical direction. So therefore, we resolve this force. One is in the horizontal direction, one is in the vertical direction. So this is the opposite. So it has to be 40 times by sine alpha. And then this one is adjacent. So that would be 40 times by cos alpha. And then we know sine alpha is 3/5. So 40 times by 3/5 should be 24. And then this one, 40 times by cos alpha, 4/5, put in the calculator, should be 32 newtons. So that would be all the forces we have. Okay. And then part A is one task we will call the acceleration. So because the particle is only moved in in this direction. So that means a force which is in the vertical direction should be like in stationary. Yeah. So force go up should be force goes down. Otherwise, the particle will not move like this. The particle will move like that. Yeah. So because the particle only moves in the horizontal direction, so the vertical direction, the force is balanced. So up is equal to down. So force go up is 24 Newton goes up, and the normal reaction R goes up, and then force goes down would be 20 G. So we just let force go up equal to force goes down. So R plus 24 is equal to 20 G. So that means R is just equal to 20 G minus 24. So that would be the first equation. And then because the particle is moved in the horizontal direction, so as long as it's moving, so we need to use F equal ma. So F equal ma. F is the resultant force. Because it moves to the right-hand side, so we have to let the force to the right equal to force to the left. So force to the right will be this one, 32 newtons, and then force opposite to the moving direction is the friction, 0.14 R. So we have 32 minus 0.14 r is equal to mass, which is 20, times by acceleration, which is what we're looking for. And we already know r is equal to 20g minus 24, so we can just put inside. Right, then acceleration is just 32 minus 0.14 times by 20g minus 24 all over 20. So I just put all that in the calculator. So we should have, let me see, 32 minus 0.14 times by 20g, so 20 times 9.8 minus 24, close brackets, and divide by 20. So I will have 0.396 meter per second square. That will be the acceleration. Let's have a look at part B. So the crate is now pushed along the same floor using the handle. The handle is again inclined at the same angle alpha to the floor, and the thrust is 40 Newton as shown in figure 2 below. And we want to explain briefly why the acceleration of the crate would now be less than the acceleration of the crate found in part A. Okay, so let's just label all the forces. So 20g, the weight, same as before, and that will be a normal reaction R here. And then resolve this 40 Newton either in the vertical or the horizontal direction. So it'll be look like this. And then because this is the starting point and that's the end point, so it has to be, because it's a vector, so it has to be goes down first and then goes across. So this one is the opposite. So that should be 40 sine alpha. And then we already work it out as 24 newtons. And then this one in the horizontal direction, that'd be 40 cos alpha. That'd be 32 newtons. And don't forget the friction. Yeah. So friction is opposite to the moving direction. So still to the left-hand side, 0.14 R. So that would be all the forces. So for this type of question, so even they just want you to explain briefly, not means we don't need to write anything. Yeah. So we still need to lay out the equation to see how the force changes. Otherwise, it's very difficult to see. Yeah. But I don't have to solve it. You just have to lay out the equation to see how the force changes. So for the force in the vertical direction, so same as before, up equal to down. So up would be R, and then down would be 20g plus 24. And then force in the horizontal direction has to be F equal ma. So force to the moving direction 32, and the force opposite to the moving direction will be 0.14 R. So that's equal to mass times by acceleration. So if we compare to the previous one, we can see R before is 20g minus 24, and now R is 20g plus 24. And then the F equal ma equation is still the same. It doesn't change. Yeah. So from here, we can see, so because of the pushing, the normal reaction R will increase. Because before it's 20g minus 24, now it's 20g plus 24. It clearly get bigger. Yeah. And then R will increase. Well, that means friction will also increase. Because friction is equal to mu R. So as long as R get bigger, then friction will get bigger. And then now we know friction get bigger. So 32 minus friction equal to mass times acceleration. So now you have a bigger friction. So that means the resultant force is smaller. So if the resultant force is smaller, so resultant force divided by 20 give you A. So A has to be smaller. So then A will decrease. So that's why the acceleration of the crate will be less than the acceleration of the crate in part A.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.